So I'll do a very condensed history of the uCloud. So uCloud is light bulbs, smart internet connected lights, but if we go a little bit back, then first the start of the light starts way back. Someone designing after he discovered the fire and light, we were able to catch it in a light bulb, and you will see that we were able to condense it into a smarter or a smaller light bulb, putting some smart chips in there. And then one moment, I think for me it was about 10 years ago, I met this guy who had a specific idea that you perhaps don't only want to put stuff on fire and have light, but you want to remote control the light bulb. So he had a light bulb with a chip in it and a magic wand in an app, and this Star Wars looking feature, which is actually a bridge with a Zigbee chip that sends the commands to the bridge, to the lamps. So when you're in your home, this is the whole new setup. You have an app that connects via Wi-Fi to the bridge, and you do the magic commands, turn light on. And then the command goes to the bridge, puts it over the Zigbee mesh network, so the lamps together with the bridge form a mesh network, and the command says, well, the command is lamp 3, turn on, and voila. So that's the in-home use system. But now we also have part of the cloud, because we are scaling the cloud. What is the cloud? In case you want to do this magic command not by your finger, but you want to say, can I say that without triggering? You say, hey, search engine, turn on my lights. Then it gets picked up, for example, by Google HomePod. It gets sent to the Google cloud who interprets it and sees the command being, oh, you want to turn on your lights. That gets sent to the uCloud, and from the uCloud it gets sent back into your house, and then we get to the point that I just explained. It can send over the Zigbee mesh network. I think in the future any of us can imagine that in this use case there are easier ways to send a command to the light that's just over there instead of going to one cloud and another cloud. But for the past 10 years and for now, this is the architecture, and there are also other use cases where you're outside of your home and you think, oh, did I leave the light on? Let me turn off the lights, but you're no longer on your Wi-Fi network. Then again, you want to send a command to turn off the lights over the internet. So the uCloud has a couple of features to enable that. One is connecting apps, so not every app can send commands to any house. You need to authorize that app. If you have an account, you need to manage the bridges, so you need to tell the system a little bit, the cloud a little bit about the bridges that are in your home. And there are some side functionality there to support the bridges, firmware updates and diagnostics. A trip down memory lane is, because as LessonUp is currently in the startup phase, self-described startup phase. 10 years ago, when I met George and he wanted to bring the U brand to life, and the U was also just a startup within Philips, and it started with a site, well, which looks kind of hip 8 years ago, and it now feels a little bit dated. And that's why the name is Meet You, because initially it was an introduction of, well, nice to, thank you. There was also an option on that's on the cloud side to also control your lights, to share some scenes. I think it's, some of you were probably, well, you were all born at the time, but not all of you were all aware of having your own PC. Moving towards the more Philips Hue marketing side, but in the backend we scaled from the initial setup. So we went live 8 years ago as one big Java Play framework setup. So one deployable to Google App Engine, and that scaled for us. During the years we moved to a more microservice setup where we broke the cloud into different pieces and put it on Google App Engine Flex, and eventually moved to Google Kubernetes Engine. And I think with that, you have a bit of context of what is the uCloud, and I'll hand it over to Herman to tell a little bit of how you built that.
To paint a picture of how we build it. Yeah. Thanks, Korjan. So those bridges and apps all over the world What infrastructure just serve those bridges? Well, it's actually one cluster at the moment. We are running about 39, I think it's now 40, it might be 41, soon 42, different microservices or applications, all running in a cluster, and there are multiple instances of each of those applications. So a pod is one instance, basically. We are over 500 CPU cores. I think we have more than a terabyte of memory in use, and with 4 to 12 developers. Currently, it's 12 because we are building features, nice new features. And we have a lot of metrics. So we have more than 100,000 custom metrics in Datadog. We graph those in dashboards. We can dive deep into what's happening to the applications, and that's a lot of extra information. But we have one cluster, and the problem with having one cluster is that it can also go down. So you might know that Google sometimes has issues as well, and that doesn't happen often, but if you, as a user, experience that you can't log into your mail, or you can't search is less often, but if you can't log into your mail, for example, that's problematic, but for us that means that all the bridges are down. And plus, if there's only one cluster and you're controlling your lights in the US, that's extra latency, so you don't want that. So what happens if we want to have more clusters? You need to manage those clusters as well. So each of the clusters need to be deployed to, and each deployment can fail. There can be problems everywhere. And if you do this manually, you need to track all of those deployments. So you need to know that they are in sync and everything is at the latest version before you can continue. So we need something to manage this, and even if you add more clusters, this becomes even harder. So you really want a tool for that. And we have been preparing for Flux, or GitOps actually, the methodology called GitOps, through the tool called Flux, since 2020. And it's a declarative thing. So you write your configuration and it will download from a central repository from the clusters itself. So if you add more clusters, they will all download from the same source. But I do recognize that there might be some of you who don't know about Kubernetes yet. So what is Kubernetes? I want to give a very short introduction. That GitHub repository is a repository on GitHub which contains YAMLs. YAMLs is a configuration language, and you see a very small snippet that is actually valid YAML. YAML that describes how to run Docker images. If you've ever run on your computer a Docker image, then you know that you define the image. You can also specify volumes, interactiveness, some environment variables. But that's a lot of hassle to do repeatedly, and you can imagine if you want to scale this to a large cloud, that's not doable. So you basically need something else. And that is Kubernetes YAML declarations. If you ever have used Docker Compose, you know that there are a little bit more options than just a simple Docker command, but Kubernetes YAMLs can do more. So you can basically define everything that you want in Kubernetes. You basically have those YAMLs and you upload them to a server. I won't go into too much detail of this picture, so don't be overwhelmed. But you upload those YAMLs to the master, and it will make sure that all the nodes follow this state. So they will run the workloads that you define. Basically the Docker image, the containers, which are on the bottom in those pods. You define where those are run. And if you, for example, want to address one of these pods, and it's part of a microservice, then you can even call a service. So you can say, just give me one of the pods of the front end, and then send a request to that, and it will route it to the right one with round-robin routing. So that's a very, very short explanation about what Kubernetes is. So you run each microservice multiple times, for example, when auto-scaling. We have the GitOps methodology, where we have those 39 or more microservices, and each of those microservices needs its own declarations of how to run that microservice. We aggregate those all into one giant GitOps repository, which is basically collecting all those different YAMLs in one file tree. But we have 4 branches. There's a branch per environment. So if you have a larger project, you typically want to have a development environment and testing environment, a staging environment and production environment. So we use different branches for that. And here's some option. If you use GitOps, so you can also use tagging. We explicitly chose for branches because it allows you to basically use the feature of GitHub protected branches. So you can lock a branch to be updated. And that's not possible with tags. Then you need to force push the tag. And those YAML artifacts are then downloaded by the clusters themselves to the clusters. We have 2 development clusters, only 1 production cluster at the moment. We're in the process of making that too. And now a little bit to explain how we do this. So you see in this picture, this is the CI/CD pipeline on GitLab. There are some steps to build the Docker image, some other stuff like running unit tests, but also some meta stuff. Once the Docker image is built, we generate deployment artifacts. That's the word that is cut off there. That's basically those YAMLs. So we aggregate those, but we include also the ID of the Docker build. And we synchronize that to develop. That is the development branch of the GitOps repo. And there's also a deploy seal dev step there, which is the old system. So to deploy to a certain Kubernetes master, you say kubectl apply. That was the old way, and now we have a synchronization to a GitOps repository. And you might wonder what is actually being synced. So here you see the GitOps repository. Inside the repository, there's a manifest basis directory, and the Cerebro was just one example of the microservices. You see that there is a .u folder. This is our own custom format. So some of you might know Helm, but we use our own tool because we have been using this tool before Helm existed. So we want to migrate to something else, but that was not relevant yet. And you see inside this .u folder, there is some templates. You see those at the bottom. Those are just the regular templates. You can name them whatever you want, but we have deployments, we have HPAs, we have network policies, different kind of Kubernetes resources you can have. One important file is the version.yaml file. This is the content. This contains per microservice the Git SHA that it was originating from in the source repository. It also contains the list of images that need to be at a specific version. So this was the image that was built in the pipeline. And only this, because this is not it's including the digest, so you cannot override this image. Then it wouldn't be the same digest. So here you see the development branch. You see the different commits happening during the day. This is all one day, or no, 2 days, but those releases happen during the day, and people can make small changes, and then they will still be deployed to the environment development cluster.
And all steps were agreed in the previous screenshot. So if you look at our presentation, then we do a lot of commits each day, and all the steps are green. Yeah. And as Remco, our project lead, is right. Remco, we do a lot of commits, and they're all green.
These dots were from a time that we didn't have a check here, but the nice thing is that you can have a timeline, so you see what is changing during the day. And this is for the development branch. There's not that relevant, but if you go to the production branch, you see what is deployed on which date, and that's very valuable if you are debugging production issues, for example. So for the production branch, we do something special. I thought about the protected branches feature. So we don't merge to production right away. We create a pull request for the production branch, and only when 2 people approve that pull request, then we merge it to the production branch. Basically, we can do any kind of check you want, of course, in the pull request review, but we specifically look at the changes in the Docker image. So here is a diff that is generated by bot. it will compare the two layers of the two Docker images and see the changes. So you can see per layer the file changes. So if you make a change to an application and you, for example, adjust a JavaScript file, you will see here that that JavaScript file has changed. If you also update the base image, you see that the base image has changed and which files or which libraries are updated. Typically, if you pin the base image, that wouldn't change. But if a hacker, for example, just includes some binary inside the base image, then we would see this here. So this is sort of also a security feature. You can also compare the changes of the microservice and see if they align to these changes. Too much details maybe. So this is how we create one cluster. But I said clusters. So you might wonder that if you now know how to create a cluster, you might also want to create this cluster automatically. So we use another kind of infrastructure as code called Pulumi. There are basically two vendors for infrastructure as code that are major, Terraform and Pulumi. Terraform existed first. Pulumi basically the same thing, but then with code instead of configuration. You see a small example of a Pulumi script that we have on the right. You write actual, pick the language, Go. You can do JavaScript, Golang, whatever. But it generates certain things like a cluster, or a service account, or some configuration for some other service or a load balancer. And if you don't want on a certain environment a certain resource, you just write an if statement, which is a giant advantage over Terraform, where you have to jump through real hoops to exclude and include certain things in certain phases. Yeah, and then if you run Pulumi up, you get a dialog saying this has changed or nothing has changed, and if something has changed, you can apply the changes. And it's just one command to create a new cluster that way. So that's really awesome, I think. And I think, summarizing, I think that GitOps really is something that is a requirement if you have a large team. And for example, if a lot of people go away from the team and come back, different people come back on the team, for example, you can see exactly why certain resources are in that repository, because you can see the synchronization step happening, and you can see, you can basically blame the whole infrastructure. You can then figure out why stuff is there or why it isn't there, and everything is contained in this repository. So if you never have the situation that you have a cluster running and you have no idea why something is in there. And being able to replicate this whole cluster just with a snap of a finger, that gives so much peace of mind. If something really bad happens and the cluster goes away, then you can just recreate it from scratch very easily. And also, because you have more than one cluster, you can have a higher availability. But I think being able to replicate it is a really important thing here. And we can even add more clusters. Yeah. More clusters. So in the future, we're working on new features, and we might investigate stuff like OpenTelemetry for distributed tracing, automatic releases with Flagger. So I did mention that we have multiple clusters, but you might want to do a staged rollout. Stuff like Istio to make a global service mesh, and a lot more nice stuff. And if that sounds interesting and you are excited about those things, then you can go to that website. I think that's it. So if there are any questions,
cool.
I'd love to hear them. Yeah.
Great, awesome. Any questions from the audience? Yeah.
You said that there are two people who would make merge requests, approve the merge
Two approvals, yeah. So
how do you test something in the infrastructure, which is in the merge request, it's tested on development, and it works, but now you are checking probably sanity check. But do you test to any other infrastructure, maybe in other environment before deployment production?
Yeah, good question. So I will repeat the question indeed. So the question is, how do you test infrastructure changes? Well, you saw the CI/CD pipeline, and there we have a sync develop. If it's an actual master release, then we have also the sync develop, sync testing, sync staging, and sync production steps. So those go in sequence, and if you have the sync testing, then there is also a sort of a system level test, which will fill first passes, and then we deploy to the system environment, which is a staging environment in our case. So it's already tested on a system level, but that's a microservice. And if you make a change to infrastructure which is not in microservice, but it's external to the microservice and only in the GitOps repository, you can make a pull request as well, and then merge it to the development branch, merge it to the testing branch, verify that it works. Then you can also merge it to or create a pull request for production and see that and ask for a review. They can test it on the development and the testing clusters.
So before deploying to production, you still have an environment where you can test the whole structure.
Yeah, so the dev clusters and the testing clusters replicate the whole infrastructure. Yeah.
Thank you.
Alright, we have more questions. Yeah.
I was wondering, how do you handle persistence? If you have clusters all around the globe, how do you keep the data in sync and not increase latency too much?
Nice. A question about persistence and how do we, so first of all persistence, and then how do we not increase latencies if you have global data. We do not store too much inside Kubernetes itself, so we don't run our own databases, only caches. And the data that we store in the Google services. Those are not global by definition, so we are doing some things to make it available globally fast. So basically replicating in caches, but also stuff like JWT. If you know about JWT, you can use those if you want to send some state to the client itself. So you basically generate a token, it contains some state, and if you then get that back later, you don't need to make a trip to the database.
Okay.
Alright, cool. Yeah, I think we have one more question and then.
So you were using the Google Kubernetes engine, right?
We are using Google Kubernetes engine.
Have you ever considered managing your own Kubernetes, and why not?
Well, we have thought about it. Did you ever consider running your own Kubernetes setup, your own masters? And I think we all, for a very short amount of time, considered this, but then decided that it's way better if somebody manages for you. It's not worth the hassle.
Great, cool. Yeah, I think we have to. Sorry. I think we have to wrap it up time-wise, so we have time for the other two talks without everyone getting super tired. So thanks a lot. Yeah, that deserves an applause. It was very interesting, and you guys will be around for a little bit if anyone has questions, right? Okay, cool. So let's do a very, very quick bathroom break for everyone who needs some time off, and then Tim will start up, yeah, talking about LessonUp. Yes.
Oh yeah. LessonUp is an interactive teaching platform where teachers can share, create, and make awesome lessons, which is not the most standard thing you can find right now in Kubernetes. Because we started with just VPSs, and we went to Kubernetes later. Right now we have thousands of active monthly teachers and students. At the peak level we have 40,000 concurrents, so we do need some auto-scaling possibilities, otherwise we would pay a lot for our peak load on Monday morning and no one's using it on Sunday, because that was what we did at the start, when we had like thousands of users, but then at one point it becomes financially inviable to do that. We have 2 clusters, we're also at Google Cloud, so we run a Kubernetes there as well. We only have 20 workloads, so only half of what the workloads is the same thing as a pod, actually, sort of. So half of what you has. And what my talk is about? My talk is about stateful, because you can find on the internet a lot about serverless, which is the hype of the moment. Then you have stateless, and then you have stateful. We have a stateful application, which means we have an active WebSocket open, which is permanently busy with the teacher and the students, sending the data back and forth. And you find a lot of, I had the feeling I had to include this slide because I didn't feel hip enough talking about stateful. But I think for a lot of small companies, or companies that are starting out, or who have a complex syncing problem, going the serverless or stateless route isn't always the correct route. So I wanted to show you how a stateful deployment can auto-scale correctly in Kubernetes. So what does it mean to have a stateful application? We have 2 main apps, the teacher and the student app. They are both deployed separately. They have permanent open WebSockets. That creates a very, very easy PubSub for our clients. It makes it very easy to get back our state and control our logic ourselves. And it also means we have very tightly coupled server and client bundles that we have to keep in sync. And that was our biggest issue with Kubernetes. How do you do this? Because this is easy for if you have one server, you just turn it off and you boot it up with a new bundle and give it 5 seconds and everyone is up again. With rolling updates in Kubernetes, things became a lot more difficult. So our solution, I will go into this in detail later. We have a Google Kubernetes engine Ingress, which is actually a sort of load balancer running. And the load balancer is configured with session affinity, which means that all our clients always go to the same server, unless that server doesn't exist anymore, or Google does some magic with timeouts. I get back to that. And then we have to distinguish on our server between the different type of SIG terms. Everyone probably knows what a SIG term is, right? Who doesn't know what a SIG term is? It's like a standard kill command in that one computer can give another computer, so Google can tell the server, we think you should turn yourself off, but Google only sends one of those. So you don't know if the autoscaler is scaling back, or you are in the part of a rolling update, or something else is happening. You only get one signal from Kubernetes, what is happening. So if you want to know more, you have to build it yourself. And then the client has to be graceful in the handling of migrations in case of an update or in case of the server going down. You want to know what is happening and how to migrate that. So, in part, this is the part when it comes to Kubernetes. All the things before were like generic. Our solution for session affinity and scaling with a tightly coupled stateful Kubernetes application is these 4 settings, which are the settings you can find all the way through your YAMLs, like Herman explained what a YAML is, a configuration file. Are the ones you need if you want to do something like this yourself and you want to have just like a simple app that has a tight coupled front end and back end. You need session affinity with a cookie. Cookie is the easiest one. There are other options, but the cookie is the easiest one. Of course, you need to drain your connections for a longer time. Otherwise, you can keep the server open, but the load balancer will kill the connection instantly, and then you don't have anything. And then your deployment needs to have a termination grace period. Defaultly, Google will turn off, Kubernetes will turn off your server instantly once you get the signal, and you will say, I want my service to stay alive a little bit longer so I can handle my connection closing myself. And then rolling update, we duplicate our whole infrastructure for the time of an update. So if we do it during the day, we normally do it at night because it's a little bit easier and cheaper. But if we have like 6 or 7 pods running, we go to 14 and then we go back to 7 again once the other ones go out. The default in Kubernetes is turn one on, turn one off, turn one on, turn one off, turn one on, turn one off. But then you have the state that you are in flux and you can't really control where the load balancer is sending new people, either to a server that is scheduled to go down or not, because some servers are still healthy, so you have to duplicate and then go back again. That is the easiest route. And then you need some server logic. Same thing, it's quite easy. You need to message the server. We do that via the database. There's an update coming. If he knows there's an update coming, he can stay alive longer. What you have to do in Kubernetes is you can fill your readiness probe, and then the load balancer will not send you any more new clients. So that's how you can tell Kubernetes for I want to keep the server, but I don't want any new connections. But because of the cookie you applied earlier, current connections will stay open and they will stay there until they hit refresh. Magically, that works. And then they all go to a new server that is part of your new settings. So then you can prepare a response for the client, because you have to tell the client itself what is happening as well. And then you have the client. He will probe the server to keep alive. And if the server says, I'm going down, we show a notice that says, there's a new version of LessonUp available. Please refresh now. Otherwise, you will be automatically refreshed in half an hour. And most of our users just press that button instantly because we will restore their state, everything will work. But you want to keep them a little bit of space. Don't refresh them under their nose. They could be teaching to 30 students and be in the middle of a quiz question or something like this. We normally don't deploy during the day to make sure that the hindrance for our users is as little as possible. But they could. We also have a teacher in America right now that makes our window of deployment getting smaller and smaller, and once we grow all over the world, we probably need multiple clusters as well, so we can deploy at night everywhere so we don't interrupt teachers during their class. Well, right now we still have to annoy some teachers that are teaching somewhere in the world because we want to deploy it in the evening, and that is when America is live. So, multi-clusters, yeah. We will get back to the U team and talk about multi-classes in the future.
You have our number.
I actually talk to Herman quite a lot with Kubernetes problems, because if you ever have a problem, you know his Twitter. He knows everything.
Not only Kubernetes.
And then the same thing, the force refresh after timeout, and then if there's no update, the client knows that, because otherwise the server would have told him, and then he can just silently reconnect to another server, and because they share the same client and server bundle, they can just silently reconnect. You don't need a refresh. And this is in a very short, I thought my talk would be a little bit longer, but this is in a very short way. So a lot of type questions, a way how we used our current setup and brought it to Kubernetes so we could enjoy the containerizations and the auto-scaling and all the nice things Kubernetes has without completely overhauling our complete code base going stateless or serverless even. We are actually taking out small parts of our original application and turning them a little bit more stateless and a little bit more serverless so we can scale in the future. But I think for especially companies that are starting out, the traditional client-server combination is really, really good and it lets you iterate very fast. The internet is full of very like projects that probably scale like hell, that don't have any users. We chose to be a company that first have users and then when we have scalability issues, tackle them head on at that point in time. And I think this is really a good setup to do that in that kind of way. There's traditional client-server combinations. This was my talk, and now to show you that LessonUp is really interactive. Because of the time I didn't put a lot more interactive stuff in there, I put one open question here. So if you have any questions, you can use. Oh,
It's updated.
You close my pin thing. Yeah. Yeah.
Yeah, so you guys can grab your phones, go to lessonup.app.
We chose to do it without the music. Maybe my sound is on, but my sound isn't plugged in here because we do have bleeps and boinks and stuff because you need to have bleeps and boinks and stuff if you want to cater to high schools. But my sound isn't plugged in. So lessonup.app, lesson with an O. I have to tell them for Dutch people because we got a lot of...
It's on your sweater also.
Yeah, it's here. And then normally, this is the open question that would normally be used by teachers. Oh, I can show the pin code again. To ask their students a question, so I'm really not using it as the way the normal teachers would use it, but it is fine to use this way. Who has a question? If you don't have a question, you don't have to add anything, but you are allowed to add anything. I will open the question of Chris. Yes, thanks for asking. We are also looking for developers who want to help us scale this awesome interactive app. In Dutch?
Dutch platform.
It is a Dutch platform, yeah. Could you?
So if the classroom, in this setup, we're doing a lesson or doing something interactive together, with the updates, can you update the whole classroom at once? So I can imagine you roll out features where all of a sudden during the quiz, the teacher has a new feature and the class is on the old version.
We normally, yeah, we can, of course, update the student and the teacher at the same time. Hmm? Oh.
The question is kind of on the board.
Yeah, in Dutch. If you have a breaking feature that is that they have to update the teacher and the student at the same time, how do you do it? You pick an awesome time when there's not that many people online, and you do it then. But we can, of course, update them at the same time. We can't force the whole class to press the update now button. So no, that's a small edge case, but we haven't found any issue because then they probably can't join and there's a button in the top that says refresh and then they can join. So I think it would solve itself, but thank you for the question. Someone is trying to inject SVGs, very good. Wesley, you can see the question. What tech stack does the application use? Everything is JavaScript, so it's all node-based in the end. The current application you're looking at is using Meteor, which was very hip and happening when we started 6 years ago. We were building all of our new stuff, we're building in traditional Node Express. We also have some Python and some stuff there and gluing everything together, but the core, 90% of it is Node-based, so JavaScript-based.
The front end?
React, and some of the old stuff is Blaze, because that was the templating engine that got bundled with Meteor, but we're writing everything that is new in TypeScript and React. Oh, and the database is Mongo. That may be also part, and so there's some Redis thrown in there. You get the drill. How many devs are working on LessonUp? If you include our founder, who's also a dev, we're with 9, I think, right now.
The answer is not enough, right?
And the answer is not enough, yeah. And then Herman, who has the last question. So Herman. Actually, we didn't have any trouble with Google. Google fixes this for us. Google is awesome. Host your Kubernetes in Google. Now we haven't found any trouble with Google turning off nodes unexpectedly afterwards. So yeah, we have.
Or does everything fit on one node? Does everything fit on one node? That's also possible.
No, I think we have several. No, we have one cluster. The last time I checked during search, we had like 20 or something. But we do have quite small nodes, so we try to keep them small so they can go out without any hassle. So you can make your nodes as big as you want. We kept them quite small to isolate problems and to make sure that Google can scale them up and down easily, because the overhead for a node isn't that high. So, but you can do your configuration of how big your node gets yourself in Kubernetes. Any more questions?
There are quite some more questions. There are also more pages, I think.
No, there's not more pages. There's one test. I have to check quite a lot. We start today with 4 instances of our teacher and 7 instances of our student, and it goes up until I think 20 or something instances of the teacher and 30 something instances of the student, and they all use roughly 1 CPU each. And then we have like a whole fleet of auxiliary applications like background workers and admin environments. So not 550 like you. I would say in the 50 to 100 range somewhere during the day.
And I think Wesley's questions do. Yeah. Right. Top, yeah.
Rewrite glue code. Yeah, that is. We do turn off. I think we have turned off LessonUp 2 times in the last 2 years. Because we had that big a migration that we couldn't handle that with making sure that no data was lost. But the last time I did it, I started Sunday evening at 11 and I finished Sunday evening at 1, and then the migration was done and we could boot everything up again. So that was our current solution, is still going down. There should be better solutions, but it is, for especially complex data migrations, it is still the only one I really truly trust. If we go multi-cluster, we can probably do something else. But right now, the last 2 times we had a very big migration, we just turned it off. Because we really have traffic during office hours. So our traffic is really, because it is teachers with students. There are some students making homework, and it's a minor inconvenience that we turn it off at 11 at Sunday. But we can. They don't mind. They can blame us. They can blame us.
My lesson of my homework.
My homework, yeah. But our traffic is really predictable, so we can find a decent window to turn it off. That's it, I think.
Yeah.
Then I turn it over to Lennart.
Right, thank you, Tim. We're a bit pressed for time, I see. I'll keep it short. So, who am I? I'm Lennart. I'm a senior software engineer at LessonUp. I haven't been at LessonUp as long as Tim has, only 5 months instead of 5 years. Before this, I ran my own startup as a co-founder of Shipwright. And in that capacity, I also started with Kubernetes. Like Tim already mentioned, usually in startups, there's a sort of constant struggle between doing things quickly and doing things properly. So we started out quickly, just using some PPS and some not very scalable code. And at some point, we had to scale because it was becoming unmanageable and too costly. Then we started to do things nicely, a bit too nicely, because we also wanted to use Terraform in conjunction with Kubernetes. And as Herman already mentioned, Terraform is a bitch. So it wasn't a very good fit for us at that time because we didn't know Kubernetes, we didn't know Terraform. So it was really difficult to get that started. It's a really difficult, steep learning curve. Already if you just use Kubernetes standalone, it's already very difficult to start with. But one of the things that we did use and that I did really like is Helm. And that's what my talk is about this evening. So, the contents of my talk are what is Helm, why would you use Helm, and how can you use Helm. So yeah, let's quickly dive in. So what is Helm? If you look at their website, it's the package manager for Kubernetes. But if I'm really honest, this raises more questions than it answers for me. It's just very vague, very abstract, and I mean, it's not just a simple install, right? You have to configure your application. It's not a one size fits all. Like, for instance, if you use the package manager of your operating system, or if you use npm to install a dependency. But if you dig a bit deeper, and also they have quite a good documentation, you'll see that it actually does these things. So it allows you to create sort of reusable templates, which they call charts, to keep in line with the navigation, with the nautical theme. It allows you to easily share those charts, so there are repositories where you can download these charts, and many big applications also publish them there. It allows you to easily install and uninstall these charts from a Kubernetes cluster. And it also helps you to really make it easy to upgrade or roll back your entire application. So, there are a couple of core concepts here. So, I already mentioned one, the charts. This is sort of like a template. If you're familiar with Kubernetes, you write a lot of YAML. And the chart is basically your YAML. But instead of just being a regular YAML with everything filled in, it contains variables, it can contain function calls, so it's more like a generic template that you can reuse. And how do you reuse it? You combine it with config, so this is your specific config. So for instance, a certain database connection password or whatever. And when you combine these two, the Helm client running on your machine will generate the Kubernetes manifest YAML files, which you can then apply to your Kubernetes cluster. You could do that with the command line tool from Kubernetes itself, kubectl, but you can also use the Helm client to do this, and that's actually quite nice because then it also helps you to easily upgrade your entire application and also roll back, which is also sometimes quite difficult. And every time that you combine a chart and a config, you get a release, and that's the thing that's actually running on the Kubernetes cluster. So, why use Helm? I already brushed upon it. You have less repetition, because you have a generic template, you can reuse it multiple times, and you don't have to continue copying over your manifest files. This also makes it less error prone, because you can imagine that if you're testing something in your staging environment and then you want to put it into production but you forgot to update some of your YAML files, your config, it might suddenly not work while it did work on staging. So then it helps to have this very generic template. And it also simplifies your release cycle management. So if you're a bit familiar with Kubernetes, you know that you can do things like rollback of a deployment, but then it only rolls back only your deployment, but it's just one of the resources of your application, because you also have other things like a secret in Kubernetes and a couple of different other resources which won't be rolled back. That can cause issues if you updated your secret, update your application, and then all of a sudden your application doesn't run, and you roll back your application, the secret stays the same. So then your old version is using the new secrets, which might cause a problem. If you use Helm, it's very easy. You can just use Helm rollback as a command, and it will roll back all the resources of that release. So, how to use Helm? It's actually really easy. But nowadays you just have to install the Helm client on your machine or in CI, which you can just install with brew if you're using Mac, so you can just use your favorite package manager to install it. And you need to have access to a Kubernetes cluster, of course. And to show how easy it is, I was attempting to do a live demo, but I'm not sure if we have the time. I'm already out of time, actually. So.
It's 3-4 minutes, right? Is everyone up for a small live demo? Yes. Let's do it.
So this is also really. I hope it works. You know, live demos doesn't usually work, so bear with me. Yeah, perhaps let's. So I created a really simple Express application, just using a generator, so it's just in JavaScript and extremely easy. And it does just one thing, it renders a very simple template with a custom message, which it receives from the environment variable. I created a simple Docker file to make an image of this application, but now we want to deploy it on Kubernetes. So I made a local Kubernetes cluster, which you can just use with Docker for desktop. You can just go to Kubernetes, enable Kubernetes, and then it runs locally. And now I want to create a chart so that we can deploy it. So how do you do that? You just type Helm create, and then we can call it demo charts. And now it will create a new directory here called demo charts. And this contains a couple of things, like the chart YAML. This is sort of the basic metadata for the charts. The most important things are actually in templates. These are the things, every YAML inside this template folder is rendered using the config. And eventually these are the YAMLs that will be deployed to your cluster. So if you're sort of familiar with Kubernetes YAML files, you see that it's very similar. But there are a couple of things, like including certain variables, some logic, so you can conditionally include parts of your YAML or not. Yeah, so basically when you do Helm create demo chart, you already get something nice out of the box, and usually you have to fine tune this, of course, but it's fairly usable. I only have to change a couple of things to get this working. So what do I have to change? In this case, I'm running it on port 3000, so I have to change my container port. And I also mentioned that we have an environment variable, so I also have to add that. So it was called message. And the value is not a hard-coded value, but it actually is a variable. And where do we define this one? It's all in the values YAML. These are the things that are dynamic. These are the things that can change for each of your releases. So what we have to do here is, well, we're using my prepared image, Helm demo image, and I have to set up this message as variable, which is by default an empty string. Okay, so now I have my chart, which I can deploy. So what I mentioned before, you have to have a chart and you have to have a config, which contains your specific configuration for this release. So we can do that here. We can just create a new file. Move it. where is it? We'll just create a new one. So we call it config YAML. Move it over here. Okay. So this contains the specific config for our application. So in this case, I want to say hi world. I don't know, just a nice variation. Okay, so oh yeah, and also I don't want to create a service account in this case, so I want to add that as well. So I'm just overriding the values that I want to change. And now when I do Helm install, I can create a release. I call this release 1. I can choose the chart. You can get this from a repository, or you can just define a local chart. So in this case, it's demo chart. And now I define which values I want to use. So I have created this config YAML, and I'm saying that I want to use the values inside this config YAML. So when I do this, it will create all the resources on my Kubernetes cluster, and it also contains some handy notes to get access. So I'll do this to set up the port forwarding. And now, fingers crossed. So it should be at localhost 8080. Oh, it just works. Great. So that's how easy it is to deploy something with Helm. Now we can actually very easily change things, like instead of doing a Helm install, we can do a Helm upgrade and give different values, and then it will just update the entire release. Or we can create a new one called release 2 with a different config and run it next to the other one. So then we just reuse what we already have. So yeah, this concludes my talk. I'm happy that it worked out. In one try even, so not bad, if I may say so.
And Herman said it was difficult to run a Kubernetes cluster. He was in it. Yeah.
A single node. It's not a very good Kubernetes cluster, but it works. Okay, so yeah, thank you. So this was my presentation. So I hope you enjoyed it. If you have any questions, please raise your hand.
I have one actually, because you recently also started implementing this in LessonUp, where we already have a live Kubernetes environment. How difficult was it to actually do this in a live environment, like mix this in one?
Yeah. So the difficulty there is actually that because we continuously copied our config, they grew apart. So first I had to check what is actually deployed on our test, what is actually deployed on our staging, what is actually deployed live, and then try to create a sort of generic template that covers all of these instances. So it's really just looking at what's currently there and trying to adapt that. But ultimately it deploys the same kind of files to Kubernetes. So if you can just replicate what's already on there, then it's fine.
Yeah, right. Also highlights our need for it, I guess. Yeah. Any other questions?
Yeah. All right. Well, if you remember it, please let me know. Yeah.
So,
Korjan?
let's say, for example, you have written your own custom tooling because Helm was not there when you needed it. Would there be any advantages moving to Helm? Is it a big part of the footprint, or would you advise anyone in every situation to move towards Helm?
Yeah, so to repeat the question, suppose that you have your own custom tooling to do sort of the things like what Helm does. Is it worthwhile to switch over to Helm, and how would you do that? So yeah, Helm. The nice thing about Helm is that it's community driven and it's backed by quite some big companies, so it's moving quite fast. So that could be an advantage. But yeah, other than that, it sort of does the same, right? You have like your template, you have some templating language in there, and if it works for you, the templating language as it is now, not necessarily. But it does also offer some other cool stuff, like sort of hooks that you can use, like when you deploy something, you can run a hook to check something, or perform a migration or whatever. So it does some extra things as well. And also what I mentioned before with the rollbacks, that could also be an advantage, that you can easily roll back a version and just roll back everything, all the resources of a version, of an instance.
I'm planning to roll back the whole cluster.
Then I would just suggest new Git and start over again.
Thanks.
Yeah?
Are you making use of any of the standard public available charts? Can you give an example?
Yeah, so the question is, do you use any of the standard existing charts? And can you give an example? Yes, we actually did. Well, not in LessonUp, because we just recently started converting some things. But in our own startup, we used RabbitMQ for the message queue between certain microservices. And they have a very big Helm chart, which really helps you to create a high availability RabbitMQ cluster within Kubernetes. And it really helps you to easily deploy that. You just have to give a bit of config. You don't have to know all the specifics of getting a high availability RabbitMQ cluster online. And it just does that for you. So yeah, that really helps.
Right.
Yeah, you remembered it?
Yeah, I remember it. It was related to GitOps. So we recently learned that the team uses GitOps for their deployments. Do you guys also use something like that? Or?
Yeah, so the question is, do we actually use something like GitOps as well? Well, as I mentioned with my previous startup, we did use Terraform to at least specify a part of our cluster. But to be honest, it was more or less dragging us down actually, because we didn't have any experience with Kubernetes, we didn't have any experience with Terraform. So if we had to change something, it was really it was difficult, because you have to see how does something work in Kubernetes, how does something work in Terraform, and make the two work together. So yeah, eventually we stopped actually maintaining our Terraform, which is perhaps not a good idea, but so we sort of abandoned that, and just we also use Google Kubernetes engine, so the managed Kubernetes, and also Helm for the deployments itself, but not any GitOps, no. And also in LessonUp, it's not, we don't do that. But we might in the future.
We might. It's a combination of GitHub actions and shell scripts. Okay. Which works for us, but yeah. we can still improve, yeah. Okay.
So yeah, I think the thing is, you have to look at the phase where your company is in, and if it makes sense. You know, if you already have lots of experience with this, you might implement it and then it's fine. But if you're in early stage, and you don't have any experience with these kind of tools, I would suggest you don't do that, and just start with something easy. Just Kubernetes is difficult enough already. So just let Google create your cluster and just roll with that. And then later on you might add some GitOps as well.
Would you say that Helm lessens the burden on the developer for deploying applications? Because now you have Kubernetes and Helm that you need to learn instead of just Kubernetes.
Yeah, so the question is, does Helm help you, or is it a burden? I think it does help you because Helm is actually not that hard. As you saw, the YAMLs that you see here are mostly just what you have to deploy on Kubernetes anyway, except we have some values here instead of hard-coded values where variables, and we have a couple of logic things, some if statements or some function calls or whatever, and it actually uses the Golang templating engine. So if you're already familiar with that, there's not really a learning curve. And as you see, they already give you quite some interesting stuff already out of the box, so that really helps. I never had to do any really weird stuff with writing my own complicated functions in a chart or whatever. It's usually quite straightforward. So no, I don't think the learning curve for Helm isn't that big. It's more the learning curve for learning Kubernetes. But if you manage that, then Helm should be easy. And especially the functionality where you can easily install, upgrade, or roll back, it simplifies that compared to a regular kubectl apply. So I would say that it would help, and it's not really a burden.
Want to take this to the bar? Because I think.
Sure.
All right, cool. Well, thanks a lot, Lennart. It was really interesting. So, just a 2-minute wrap up. Yeah, I hope you found it interesting. You learned a lot today. Everyone who gave a talk will be around for a little bit to ask more questions. And we're doing, so we're planning to do this on a monthly basis, so every last Thursday of the month. So our next tech meetup is on the 28th of October, and it's about scaling your tech team. So I think might again have a LessonUp speaker, because we are very good at making mistakes and doing good things, scaling up slowly. But for now, yeah, please have a drink, and I hope to see you soon in a month.